Welcome back to my home workshop. Today I'm going to start a new series, and this is a little lathe that I bought many years ago. I started to renovate it many years ago when I had much less experience than I have now in a workshop, and I thought it was a good opportunity to come at it with fresh eyes and see what I need to do to make this into a machine that I can actually use. Well, as you can see, it's a very small machine. It's in fact 2¼ inch center height and approximately 7 inches between centers. It came with minimal attachments. It's merely got this faceplate, and it didn't come with any centers. The bed, as you can see, is an unusual design. It's a bar bed with a round bed on the front, 1 inch diameter, and a nominally 1 inch square section on the back, so it runs on both those. It all feels nice and tight and smooth. Of course, it needs adjustment. The discoloration actually isn't as bad as it looks. This is not rust, this is grease. I greased the whole thing up for storage, knowing that I wasn't going to look at it for many years. You can see that I started to work on a belt drive for it. So it's got this cam action gear change, which seems to work okay. At the time I didn't have access to larger sections of aluminium, so I actually made the pulleys for the primary drive from the motor from wood. We can look at all that later. It looks like quite a well-made machine. I don't know what make it is. There's no identification on it whatsoever. So if any of you recognize this, I'd love to have any information from any of you who might know. It has dinky little tailstock, which includes setover. It's got adjustment in the ways here on the round section of the bed. Let me just swivel it around so you can see better. So underneath it has adjustment here for taking up any slack. The cross slide isn't actually mounted properly because these guide bars on the slide were missing. It's very simple, as you can see. Doesn't have a rack and pinion, it just has a lead screw. It looks quite well made. I just think it would be a nice little machine to do up, and I think it would make an interesting series. I took a little time to measure all the critical dimensions of the lathe and put them into a 2D CAD program. This is really helpful for me because it means that when I'm away from home and don't have access to the workshop, I can still do a little bit of work on the project. It also means that I'm better prepared for when I do go back to the workshop and can use that time more effectively. This photo shows how I measured the positions of the holding down bolts and the hole for the cross slide nut using my recently acquired purchases, 2 parallels and one of those pins. And I'm using here the faceplate as a reference, as a datum. So I want to upgrade the cross slide. Originally it had slots down the side here and L-shaped gibs. Now that doesn't allow for easy adjustment. So a long time ago what I decided to do was to replace the whole cross slide with a new arrangement, and I started to fabricate this on my lathe, something like this. So it would have operated like that, a fabricated structure. Now the problem with that is, there are 2 problems in fact. The first is that it increases the height too much, so that if in the future I want to add a top slide, there won't be any room left, and that's because it's fabricated. The second issue is a bit more pragmatic, since now I perhaps have a more realistic view of what I can attempt and how long things take to do. So what I want to do is continue to use, in the first phase of the project, the existing cross slide and modify it, so replace that slot with a dovetail on both sides. So here's a detail from my CAD drawing showing the original arrangement with the L-shaped gibs on the left and the proposed arrangement on the right hand side. You'll notice that the gib strip, the adjusting strip, is on the left hand side closest to the headstock. That's because normal cutting forces will push the cross slide into the right hand dovetail. It means I can basically use this material, but the dimensions have to be changed. It has to be narrower and thinner. And so I'm going to have to take that over to the shaping machine to modify that. This needs a little bit of thought because this is cold drawn mild steel, and by its very nature it has inbuilt stresses. And so what you find is that if you cut a piece of stock and remove material from one side, when you remove the clamping forces, you'll find you end up with a bend in it. And so what we need to do is we need to approach the finished size with roughing cuts, preferably removing material from both sides, and then leave a finishing cut at the end just to make sure that things are straight. So we're going to have a look at the shaping machine and see how I propose to hold this. Well, this gives an idea of how we can cut the dovetail. So the top slide is set over to 60 degrees, and we've got a nice edge there that we can support this off with a couple of clamps. So that's fairly straightforward. That's not the main problem. The main problem is how to reduce the thickness of this, removing material from the bottom and this side. Obviously, you can't grip it like that in a vise with just one flat edge and one pointed edge, and that not in the middle but on one side, so that's not going to be stable. It's going to rock like that. It's too long to hold that way in my vise, so I need some other way of holding this. So what I propose doing is I've cut a piece of stock here, and what I'd like to do is make this into a little jig which I can use for similar jobs in the future. So it can be attached with the holding down bolts that will be used in the final application, and this can be bolted down onto the table, something like this. So that way I can hold this firmly, I can take roughing cuts on both sides, and hopefully we can narrow this down to the right profile. Well, it's actually been a couple of days since I've done any videoing, and that's because I needed to take time out to produce this little jig. I also went ahead and produced the first gib strip so that I know that I can complete the processes, and the second one I can video and show you how I have gone about this. So let's go over to the shaping machine and see how this is going to be used. It's basically just a 1/2 inch by 1.5 inch piece of BMS. I've shaped it so that it's got relief underneath, so that it's got a definite surface to sit on the table with, and then it's relieved on the sides with the top surface just finished, the top and the bottom finished, so that I can mount the gib strip like that with counterbore holes underneath. So that gives a nice rigid setup, and I can just clamp this on the sides like this, and that gives me full access to the surfaces that I'm going to need to get to. Now, as I mentioned before, you need to remove material from both sides, otherwise you'll end up with a bowed piece because of the inbuilt stresses in the material. So that's what I did. So it ended up being quite a few passes necessary to remove from the jig and replace, but that's fairly convenient once you set it up. Now, the other encouraging thing for me, and the other reason why it was worth taking time out to do this, not that this is an expert piece of workmanship whatsoever, but it was encouraging for me that this gave me an opportunity to see how accurate my machine is. Basically, I was very happy with how true this machine cuts, and if we take this over to the inspection table, we can just see how well it's come out. And of course, just to remind you that I'm cutting on both sides, it was quite noticeable. Even relieving these channels, it resulted in the underside being bowed, and you can see I've had to remove material from the ends on the shaper. So let's just take it over to the table and just see how true it is. So using some of the equipment I just recently purchased actually, so that's very satisfying. I've just set this up and just zero this I don't think you can see this on camera, but you'll probably just have to take my word for it. As I move the stylus around, apart from some of those areas which weren't finally machined, this is within, it's within 1 thou of deviation across the whole surface. So that's no credit to me really, it's credit to the shaping machine. It's cutting well, and that's very reassuring. So that's the first time I've actually checked this, but in a job like this it's going to be important. Of course it would be possible to get around that by packing up one end of the work to compensate, but it's just reassuring to know that I didn't need to do that. In fact, I changed this end for end as I was working, and I came out with a good result. Now, before I can mount the gib strips, I've got to finish tapping the 2BA holes. So I always like to make sure that it's square by using my small drill press, and just to get the tap started and then finish off by hand. Some of you might think this is a bit pedantic, but I think it's wise to start like this. I've actually counterbored the holes on both sides because we're going to remove material from both sides. There's no point in tapping the whole lot, and that just makes the job a bit quicker. So I'm just using a bit of tapping compound. If nothing else, it helps remove the chips. 2BA. Try to avoid the BA taps these days, they're quite expensive. But since that's what I have in the machine, I've got to stick with that. So just screwing the gib strip to the jig. These are just counterbored enough to prevent them from fouling the table. I wasn't sure to start with whether these were going to be sufficient, but there's no sign of movement or distress or anything, so this seems to be quite successful. So I'm taking a roughing cut here, so I'm not too worried about surface finish. So I'm going to remove about 50 thou from both sides initially, and then that will leave space for the finishing cuts. And of course, when I take this off the jig, I expect it to be bowed. Okay, I think that will do for one side. So we need to take the jig out and turn the work over. Now at the moment, because of the rigidity of the jig, this is flat, but I'm quite sure that when I unscrew this, it will be bowed. Let's go and have a look. Okay, while still on the jig, just traversing this, and of course it's a very rough surface, but yeah, that's straight. Difficult to tell exactly with the rough surface finish, but yeah, that's straight. So let's see what happens if we remove it from the jig. Okay, with the gib off the relatively stiff jig, I've zeroed it at the end, and that's 6.5 thou high in the middle, and then at the end we're back down to 0. So we've got a bend in there of 6.5 thou we didn't have beforehand, and that's all due to removing material from a stressed component. I've done a little bit of reading online on this topic of cold rolling or drawing, and in reality most flat section or rectangular section material is cold rolled, and it's only normally round steel, i.e. bar or tube, which is cold drawn. But the effect on the material is actually the same. So here you have a couple of rolls and you can see the material going through, and it's merging on the right hand side with a narrower section. Now there's a little experiment that can be done. If you put 2 sheets of material back to back of half the thickness and put those through, the material emerges on the right hand side looking like this, sort of curving outwards. Now you can imagine if you applied a force on the end there or along the length and you squeezed it back together so it looks like that, then you will have induced stresses into the material. So you'll have compressive stresses on the inner surfaces and tensile stresses on the outer surfaces. So it looks like this. And that's in fact what you find in cold drawn or cold rolled material. I don't know exactly how that happens, why it is that the center section is extruded more than the other, but it is. And the effect is exactly the same if you go through a die in a cold drawing process, i.e. for tube or bar, round bar, or for wire even. Now what's the effect of removing material from the upper surface of a section like this? So you can see that the hatch line, that's material that we're removing, and you can see that the material as it was before had tensile forces on the lower surface, compressive stresses on the upper surface, but it's held down in the jig as in my operations here in this video. So in effect the central bolt is keeping the material flat as it's stressed. So if you remove the bolt, the stresses will cause the material to bow upwards at the center to minimize the loading in the material and just equalize things out. And that's in fact what you find. Of course, the other way around this problem is to stress relieve the material. To stress relieve cold drawn mild steel, you need to take it up to 650 degrees C and hold it there for about 1 hour per 25 millimeters or 1 inch of thickness, and then to cool it slowly in air. That's not the same as normalizing, which changes the crystal structure, but stress relieving would have been an option. I don't have any heating facilities at the moment, and I wanted to use the material that I have available, so I didn't want to change to hot rolled mild steel. The other slight advantage with cold draw material is that the surface finish and machining is sometimes better, and it should, theoretically speaking, be slightly harder. So by removing that material, it's gone upwards, balance is lost. I suspect it would have been even more had I removed it from that side, which we're going to do in a minute, because this is a bigger cross section compared with that. So there we are, that's something to be aware of, and that's why I'm taking roughing cuts and then finishing off later. Now I'm going to have to think a little bit about how I mount this for the next stage, because you can see just how bowed it is now. Look at that. That's a graphic illustration of the effect of stress in cold drawn material. So I'm going to think a little bit about how I mount this. I might want to not tighten this right down, or put some packing underneath there so that I can take another roughing cut, balance up the stresses a bit, and then we'll take a closer look at this for the finishing cuts. Well, that's all we have time for. I hope you join me next time for the second installment of upgrading this small lathe. Thanks for joining me.